So here's problem 2 for homework 16. We have this, the UHart ASCE student section has designed the truss shown. Wow, there's a lot of typos here. And with the applied loads of 10 kilonewtons and 10 kilonewtons and 15 kilonewtons and 15 kilonewtons, and the dimensions are 3, 3, 3, 3, and 2 and 2, and we wanted to determine the forces that are right in here and here. Okay, so I'm looking at this, and I had a plan of attack that I liked, and now I'm starting to reconsider it. I thought I could do this in like one step, but I was thinking that we were going to look for. No, I can. So I'm going to do yes. Okay, so I'm going to keep with my plan. So here we go. What I'm going to do first is I'm going to take a free body diagram of the entire thingy. All right, so let me put him in here as a quick diagram here. I guess I'll make it. It doesn't matter. Here. Oh. I'll fix it. There you go. Make it look like it's supposed to look. Okay, so here's my FBD of the whole thing. So I have a force right here. That's going to be my RM. And then I have a force right here that is RAY. And here you go. Coming in this direction, actually, RAX. And we have a force here. And a force here. And what are these going to be? These are the B and C are the 10 kilonewtons. And then we're going to have a force coming down. And a force coming down. And these are the 15. And so what I'm going to do is I'm going to take the sum of the moments about A. And I don't even know if I need to find those reaction forces. I think I have a scheme where I can get around it. So I'll start out with RM. That's going to be times, what are these? Each of these is 3, right? So 3, 3, 3, and 3. So it's going to be 12. And now we have, the rest are going to be clockwise, right? They're all clockwise. So they're going to be, I said clockwise and I put a negative sign right there. I mean a positive sign. So I say 15, and there's 3 and 3, so this can be 6. And then it's going to be another 15, but now times 3. All right, and then I need to come down to the next line over here, and I'm going to have a negative 10, but it's going to be, let's do this one first. And so this is 2 and 2, so that's 4. And then another 10, but then this is going to be 2, and it's going to be equal to 0. And I will find my RM, R capital M, is now going to be 15 times 6 and 15 times 3, add them together, so 40, and then 20. All right, and then we divide by 12. So I get 16.25 kilonewtons is what I have as this reaction. And I believe I can now, what I'm going to do is I'm going to cut through, and I didn't put any of these, I should draw the diagonals in there. Let's draw the diagonals. It doesn't hurt anything to put them in there, because I was about to point to them and they weren't there, so that's the reason. We are looking for DK, so we're going to cut through here. So what I'm going to do is I'm going to cut through right here and through right there, and I'm going to take the moments about this point right there. Okay? That actually eliminates this. It's going to eliminate this, and that's going to allow me to get this force. But I know that this force, the one that I want you to get, is actually equal to that, right? And then in the y direction, I'm actually going to be able to solve for this, because first I'm going to get this angle right in there. So let me get what that angle is going to be. I'll draw it on here, like that theta. Right? So I'll find out that theta is going to be the inverse tangent of rise, which is 2, over run, which is 3, and 2/3 inverse tan, 33.69 degrees. Okay, so that's something I might want. Now I'm going to take my other FBD of this, and here and right here. I guess I'll do it right there. Okay. Right here, and oh, I drew the diagonals wrong. Whoopsie daisies. Like that. Okay. And then our forces coming out there and not there. And we're going to take, come on. I got this guy right here, and he is my 16.25 kilonewtons. And this is F. Okay, we also have a force right here. And it is 15 kilonewtons. It's interesting. Okay. And then this guy is FLK. Sure. This guy was FDE. And this is FDK. So if I take the sum of the moments about K, once again, that's this spot right there. I eliminate DK and LK, and I also eliminate my 15. So the only thing that's left is this guy right here. So I think we're going to notice that he's actually going to be in compression. So that's interesting. But I've drawn him as counterclockwise. So he's FDE, and the distance is all of 2 meters, right there. And then, but I'm also going to have 16.25. And it's going to be 3 and 3, so it's going to be 6. And he's also going counterclockwise, so that can't be true. So we're going to take 6 times that divided by 2. So we get a negative 48.75. That's interesting. I'm going to look at this a little bit. Did I miss anything? I don't think so. It's pretty damn clever, I think. Okay. And so that's kilonewton. So 48.75 kilonewton compression. And that's also going to be, so it's FDE, which is also equal to FEF. Right? And then lastly, we could take the sum of the forces in the y direction is equal to 0. And since we have F dk, right, is coming upwards, I'll keep it as positive, but it's going to be the sine of 33.69. It's going to be minus 15 plus 16.25. So we're going to find an F dk. Let's see, 16.25 and 15 subtract. All right, so it's going to come on the other side. So it's going to be a negative number. 33.69, and take the sine of it and divide it, and we end up with negative 2.253 pounds. Therefore, 2.25 pounds. Okay, kilonewtons, come on. 3 kilonewtons compression. And I think we can fit everything on here, and I can go home and get some sleep. Answers. F, what were we asking for? dk is equal to 2.25 kilonewtons in compression, and F EF, because that's what we were asking for, is 48.8 kilonewtons compression. And I might make it home by midnight if I hustle. Good night, sweetheart. It's a 12.5-minute video.